Is outer space a starlight propagation medium?
To answer this question, I will start from light pulses propagation through optical fiber analogy.
What is transmitted through optical fiber?
From the most everyday information such as videos or chats, to scientific parameters or secret military communications.
How information is transmitted through optical fiber?
All this information is sampled in digital bits, generating data that is in turn transformed into laser light pulses that are propagated through the fiber.
Does optical fiber degrade the data it transmits?
Absolutely no propagation medium is perfect, so no wave propagation, through any medium, will fail to degrade in various ways, each caused by different optical phenomena, as I explained in my YouTube video. We used to consider photoelectric effect, reflection, refraction, diffraction, selective delays, selective opacity, etc., belonging to optics, but truly they are phenomena inherent to any wave propagation, such as sound, seismic waves, and so on. When I refer to these wave phenomena, I will be doing so in the broadest sense, regardless of whether I am focusing on the propagation of starlight through space. All these phenomena, occurring on the light pulses propagated through optical fibers, are that light degradation causes.
Like optical fiber, can outer space, empty by convention, be considered propagation medium for starlight?
It is absolutely false that outer space is empty. So, categorically yes, outer space is the starlight propagation medium.
Can outer space be characterized as any propagation medium? If outer space is not empty, what is it full of?
The non-empty outer space composition would be any matter or energy manifestation, such as all gravitational and electromagnetic fields flows crossing their borders at every instant, in their permanent or transitory regimes, intensities, frequencies, phases, polarizations, etc., dust, molecules, winds, and all types of particles, bursts and stellar radiation, and from any emitting sidereal objects or incidents, and asteroids, comets, planets, star systems, galaxies, clusters, etc.
Is outer space an isotropic propagation medium?
For reliability and transmission quality purposes, optical fiber is intended to be the most isotropic medium possible. Outer space is the opposite, as it is an anisotropic medium, and its anisotropy also varies over time.
Being such an ethereal, intangible, and unlimited medium for light propagation, how can we accurately measure or model outer space physical characteristics?
The first difficulty is we are not used to seeing the unlimited outer space as a volume totally integrated by subspaces. Subspaces I would prefer to call regions.
But is it possible differentiating these ethereal regions from each other?
Since quantum mechanics has already established a statistical mathematical methodology, based in turn on pre-modeled quantum numbers, to configure the boundaries of the atomic electron clouds, the region's delimitation or boundaries can be modeled in the same way, a primary step to be able to differentiate them. Thus, the region boundaries of space will extend to where the composition, or in other words, the isotropy of that region of space does not vary. Seen in another way, if we begin to detect changes in the composition or isotropy as we move through space, it is because we are leaving one region to enter another. Thus, the change in isotropy gives the boundaries location between different regions measure.
But, over the composition or isotropy of what we should measure that change?
Each given region compositional isotropy change will be measured on the above-mentioned parameters, namely, gravitational and electromagnetic field flows crossing their boundaries, each affected by their respective applicable regimes, intensities, frequencies, phases, polarizations, etc. Dust, molecules and winds and all types of particles, bursts and stellar radiation, and from any emitting sidereal objects or incidents. Asteroids, comets, planets, star systems, galaxies, clusters, etc.
Also, how much must isotropy change for us to perceive we have reached a boundary between regions?
The acceptable change in each isotropy is a rather arbitrary matter, and should therefore be agreed upon by all researchers. In any case, my goal was not to establish my region's boundaries quantum model as the state of the art, or a single, absolute truth, but to find a tool. Any tool would allow me to segment sidereal space into an aggregation of different and concatenated subspaces, regions, or whatever you want to call them. Regions separated from each other by individual boundaries they share. Boundaries to be determined statistically, quantumly, or however, based on, among other parameters, the deviation from predetermined ranges of each isotropy considered.
Since outer space is a propagation media concatenation for light, does it cause phenomena such as reflection, refraction, diffraction, photoelectric effect, ionization, etc.?
Once the ethereal sidereal regions have been established as propagation media for light, it is appropriate to consider them analogous to the rest of the tangible propagation media of our daily lives, such as plasmas, gases, liquids, or crystals, thus verifying they induce in it the behaviors of the optical catalog phenomena. A couple more notes regarding the space anisotropy observed. Starlight, traveling more than 13 billion years journeys to our most advanced telescopes, will have seen the isotropies of the different regions both crossed by its path and those around it and ahead and behind, transmuted countless times. Regions considered defined within boundaries where the range of isotropy is held constant over a finite time interval, but not even close to so many billions of years. And considering the sidereal propagation trajectories as concatenations of differentiated regions, reaffirms the hidden obviousness that the anisotropy of the cosmic microwave background in the universe is the sum of each isotropy of each region that composes it.
What is redshift?
In physics, redshift is an increase in the wavelength, or its corresponding decrease in the frequency and energy of electromagnetic radiation during its propagation. The opposite, or a decrease in wavelength, and a corresponding increase in frequency and energy, is called blueshift. Note neither of these definitions is tied to anything being its cause.
Is redshift detected in light pulses transmitted through optical fiber?
The intervention of various optical phenomena as a consequence of wave propagation through the optical fiber will always cause redshift in the transmitted light.
What phenomena cause this omnipresent redshift detected?
Without a doubt, neither optical fiber expansion nor any supposed universe's expansion causes this redshift. As I already mentioned, reflection, refraction, diffraction, photoelectric effect, ionization, selective delays, selective opacity, and in general all the phenomena in the optics catalog are responsible, occurring simultaneously and each contributing in its own way, for reducing the wave's energy as they propagate. The loss, the light or wave's energy wear and tear, throughout their propagation paths is what causes the redshift, which is what I call the solar effect. For sure, the relative displacement speeds of star objects relative to each other are another redshift cause in the light perceived from them. But interpreting displacement speeds as an universe expansion to which all the redshift is attributed is an error as colossal as the amount of dark matter and energy they persist in deriving from it.
Which parameters affect the amount of redshift caused?
Each indicated optical phenomena is affected to its own extent by the density, temperature, composition, and distribution of the matter or energy that make up the propagation medium.
Do propagation mediums other than optical fiber also cause redshift?
Whatever mediums the waves propagate through will cause redshift phenomenon.
So what is starlight redshift?
It is the manifestation of light energy loss due to its interaction with the different media through which it has propagated, in the billions of light-years journey from its origin until reaching our telescopes, or as I said before, the solar effect. And categorically the redshift is not evidence of the universe expansion, and even less proof of the existence of feverish entities such as the Big Bang or dark matter and energy.
Is there interinduction between infinitesimal, finite, and infinite regions? What is interinduction?
Gravitational induction, gravitomagnetism or gravitoelectromagnetism equivalent concepts were already present in Maxwell and Heaviside works before Einstein's relativity. Gravitoelectromagnetism, GEM, as a mathematical model, is the set of formal analogies between Maxwell's equations for electromagnetism and relativistic gravity. As a concept, it is both gravitational variation inducing electromagnetism, and electromagnetic variation inducing gravity. Interinduction is my gravito electromagnetic induction concept extension to also encompass its effects on weak nuclear fields and strong nuclear fields. In other words, interinduction is the multiple, simultaneous, and permanent interaction between the four fields of nature. Detecting permanent sinusoidal gravitational waves, with their extremely low frequencies, is insurmountably complex for current technology. However, solving the problem is an exciting challenge that many minds are tackling with proposals from their various disciplines. I myself have proposed in my YouTube channel 3 alternatives for experiments. It would certainly represent a huge step forward to achieve such detection, which would simultaneously confirm the existence of interinduction.
What is this multiple and simultaneous interaction like?
One consequence of the hypothesis that earned de Broglie the Physics Nobel is everything moving emits waves. And everything, absolutely everything in the universe is in motion. Therefore everything exists and moves in the universe immersed in an ocean of countless wave fields of diverse origins and types. Likewise, everything that exists is subject to interaction with each of these time-varying fields. And all wave propagation through any propagation media in the universe is degrading, and consequently is losing energy. Because no interaction in the universe is free, or put another way, in every interaction, energy conversions occur, and part of it is dissipated into heat.
Those interinduction occur only in outer space regions?
The above means all finite and infinitesimal regions also exist immersed in the ocean of all the countless superimposed waves, not exclusively gravitational, that move through the universe. So everything in the universe is subject to interinduction. When I speak about infinitesimals, finite and infinite, I am referring to regions sizing, for example, an electron, an elephant, a mountain, or a galaxy, respectively. Thus, the entire infinitesimal region's wave casuistry, that is, weak and strong nuclear fields, is affected by interinduction with the external gravitational and electromagnetic fields in which they are immersed.
How much is the influence of interinduction between the infinite and the infinitesimal?
I do not dispute the interinduction between gravitational fields and strong or weak nuclear fields, or even with electromagnetic fields, is infinitesimal, or for their use in technology its manifestation is negligible. But this interinduction exists, and it becomes all the less negligible the more precision is required in the analysis. Therefore, for universe time scales, such as those over 13 billion years, it is essential to consider that starlight will have been interinduced by all the fields it has encountered in the regions through which it has propagated. Regions acting as propagation media degrading it, due to the entire catalogue of optical phenomena with which they affected it. Affectation manifested itself as that redshift I already claimed as solar effect.
And that's all, folks. Bye-bye to the expanding universe, the Big Bang, dark matter and dark energy, and all the rest of the similar sophistry.
This video clip serves as an example to complement the idea. Differential calculus allows the profile of any curve to be approximated by a straight infinitesimal segments concatenation. Valid approximation for our current technological requirements, let's say in the solar system environment.
Los catetos y la hipotenusa van a ser el diferencial de X. Esta pequeña altura es un diferencial de Y. Es un diferencial de Y. Ya, y este arquito es un diferencial de S. O sea, podemos agrandar ese arco. Tendríamos una cosa así. Ahí más o menos, ya agrandando esto, tenemos el diferencial de X, diferencial de y esto sería el arquito diferencial de S. O sea, como quien dice más o menos la hipotenusa. Pero como son diferenciales de esa curvatura, esta curvatura, bueno, aquí está exagerado obviamente, esa curvatura es casi una recta, una pequeña recta.
But no matter how infinitesimal any segment into which we subdivide a curve, the next new and more powerful electron microscope will show us the ds differential was not, and never will be, a straight line, but just a curve segment. So approximations and other artifices served as basis for developing differential calculus in particular, and mathematics in general, will always introduce errors for certain scales. This makes it clear we are limited to roughly modeling only what we can perceive. That is, at the edge of infinity, Webb, like all its predecessor telescopes, detecting and concentrating the increasingly dim lights of the increasingly distant intergalactic and interstellar objects to which it has access, helps to shape new, previously unsuspected infinite spaces. While at the opposite extreme of infinitesimals, developments in electron microscopes are also bringing to light previously unsuspected infinitesimal regions. Both extremes show the matter of regions is also an arbitrary question of scales, or orders of magnitude. When the hypothesis of an expanding universe arose in the 1920s, there were no capabilities available to penetrate so deeply into both extremes of space, nor to glimpse the real-time scales in the universe in those spaces. With such technological limitations, the proposals of that time could now seem nothing but amateurish. LIGO was designed to detect the disturbances from massive catastrophic stellar collisions, propagated as transient, ephemeral, and powerful bursts of gravitational wave pulses. LIGO was not designed to detect steady-state sinusoidal gravitational waves, whose periods have enormous time intervals. And it is precisely these permanent sinusoidal regime gravitational waves throughout the vastness of the universe, which make up the fabric warp of the regions I have been talking about, and which submerge everything. In that respect, LIGO, tuned to a very specific and narrow band, does not behave like radio telescopes, which are comparatively optimized for a large bandwidth. Radio telescopes requiring increasingly larger surfaces to capture increasingly attenuated waves the more distant the sources to be studied. Or the Webb telescope itself, which also required a bold increase in its light-gathering surface. Putting interstellar light in the same context with the propagation media it passes through, and the corresponding propagation time scales, the interinduction influence between the infinite and the infinitesimal, or, in other words, between the gravitational and the nuclear, is incontestable.
Interinduction or space-time relativistic curvature.
To date, the only indication of interinduction between gravitational fields and electromagnetic fields, or what concerns me, which is starlight, are the breaks in its trajectory due to reflection, refraction, etc., caused by the previously proposed propagation media that it passes through. Unfortunately, these optical phenomena now have to compete for the same clue with the curved spacetime relativistic hypothesis. Before my proposition of outer space acting as a propagation medium, there was only one clue for one hypothesis, and that was the happy marriage from which gravitational lenses were born. But, as it passes through the so-called gravitational lenses, how much is the path of starlight bent by the relativistic curvature of spacetime, and how much is it bent due to refraction or reflection by and between the regions acting as propagation media? The above questions could be rephrased as, does the relativistic spacetime curvature phenomenon dominate optical phenomena, or is it the other way around? I have no answer to these questions, as they have only just arisen while I was reviewing the text of this video. Any wave's interaction with any media through which they propagate is an energy loss process by the former, part of which is incorporated by the latter, and part of which is dissipated as heat. And an infinitesimal, but permanent, and progressive fraction of the energy lost by the waves leads to a decrease in their frequency, which I call solar effect, and which manifests itself as redshift. This phenomenon is as true for all tangible propagation media, such as solids, liquids, gases, and plasmas, as it is for erroneously empty defined outer space regions. Each different propagation medium has a unique interinductive response on the waves it propagates, due to factors such as composition, density, temperature, pressure, homogeneity, isotropy, and so on. These interinductive responses can be characterized, grouped, and tabulated to make the redshift they originate a predictable and reliable variable. Everything interacts with everything else, and no interaction ever loses presence and influence within of its own scales framework, although detecting those presences and influences outside those scales is extremely difficult, if not impossible through Heisenberg, and negligible for their use in most technological purposes. An unexpected surprise emerged from this research was the discovery that wave phenomena produced by outer space regions, acting as propagation media, contribute, together with relativistic gravitational lenses, to starlight trajectory bending. And something anecdotal within this light propagating behavior is that phenomena such as reflection or refraction can bend that light trajectory in directions different from gravitational curvatures.
All this analysis has given me the basis I need to find the relationship between photoelectric effect and interinduction.
Subject of my next video.